continuing on with what we did in the last section, we are going to look at some different graphs that we can make using polar equations and talk about a little bit of symmetry, and also how we can tell what it's going to make, this type of stuff, because we're not really familiar with the polar coordinate system. We're familiar with the Cartesian coordinate system. So you'll notice that I gave you some notes about some polar coordinates and pretty pictures. So here's the pretty pictures part. And so we've got a circle, we've got cardioids, we've got limasones without an inner loop, and you'll notice that that means A is bigger than B. So in this case, your constant will be larger than your coefficient. Okay? A limasone with an inner loop will have a constant that's smaller than your coefficient. And then you'll have a rose. Okay? And notice on this one, so far, all of your arguments have been a single theta. But when we look at a rose, we have a coefficient on our theta within the argument of the trig function. And so if we have an even number of petals, then your actual number of petals is going to be half of what you see. Okay? And then an odd number of petals is if n is odd. Okay? So if n is even, you'll have an even number of petals. If n is odd, then you'll have an odd number of petals. And then the weird part is going to be a lemniscate, which is the official word for the infinity symbol, which if you turn it on its side, it looks like an 8, okay? But you'll notice that that's going to be an r squared, and then you'll have a coefficient squared, and then you'll have a double angle. Okay, so those are what we're going to be looking at, and we want to talk about a little bit of symmetry first. So if we want to talk about it being symmetric with respect to the polar axis, so remember the polar axis is going to be your positive x-axis. So if I want to know if a polar equation could be symmetric with respect to the polar axis, then I'm going to replace theta with a negative theta. So just think about that for a second. If I have some sort of, let's just say we've got a rose petal up here, okay? And if that's generated with a positive theta, that's probably not the best example, but that's just what I'm going to give you. All right, then if I replace it with a negative theta, then I'll have the reflection down here, because instead of swinging up to a positive angle, I'll be swinging down with a negative angle. So I just replace my angle, my theta, with a negative theta, and if I get the same answer, if it reduces out the same, then it's symmetric across the polar axis. When we are dealing with lines, lines are going to be in the form theta equals some angle measure. And what that's going to look like is basically the set of all points that are going to be this far away from the polar axis. So if I'm here and I go out to pi over 2, and then I'm here and I swing out to pi over 2, and I'm here and I swing out to pi over 2, here. So all of these points are pi over 2 away from the polar axis, because remember that these are all concentric circles. So I find out what my radius would be first, and then I would swing out pi over 2. Well, this is the collection of all points that are pi over 2 away from the polar axis. So I can test for symmetry with that by exchanging my theta with a pi minus theta. Okay, so you're going to shift it pi units. So swap out your theta with a pi minus theta, and then do the work there. And if you end up with the same configuration, then you find out that it's symmetric to, hang on, I just lost it. So with respect to the line, theta equals pi over 2. So for symmetry with lines, you're going to replace your theta with a pi minus theta. And then finally, if I want to change my r theta and then swap it out with a negative r theta, that's going to be symmetric across the origin, or across the pole. Because remember, what does that do? That means I come out a certain number of r and then swing up to a certain angle measure. Well, if I change the sign on r, what I'll do is I'll come out to r, swing up a certain angle measure, and then I'll slice through the pole. So if I change the sign on r, that means I'm going to be symmetric about the pole. So what we want to do now is start transforming a few more equations. We've been practicing with coordinates, and now we're going to do some equations. We've got a couple equations down. So if I have theta equals pi over 6. So remember, if you've got a theta equals, that's going to be the collection of points that are pi over 6 radians away from the polar axis. And so that's going to be a straight line. Okay, so how do I do this? Well, looking at my polar coordinates and pretty pictures, I find out that if I've got an angle measure, I can take the tangent of both sides. So the tangent of theta will equal y over x. So I'm going to take the tangent of both sides. So I've got tangent theta equals the tangent of pi over 6. Okay, well, what can I swap out tangent theta for? That's going to be y over x. And then the tangent of pi over 6 is going to be root 3 over 3. And now I can multiply both sides by x. So I find out that I've got y equals, this is slope-intercept form. So I've got y equals this slope times x plus 0. So this is slope-intercept form of a line. So you will find out that it's a line that is traveling through quadrants, because theta equals pi over 6, it's going to be the line that travels through quadrants 1 and 3. All right, so we want to do another one. I've got r equals 8 cosine theta. So r equals 8 cosine theta. So remembering that I need to have r squareds, so I only have an r. And as soon as I notice I got a cosine, I better see if I've got an r here. Because if this says r cosine theta, then I can replace that with an x. Well, it doesn't. And so what I need an r here, and then if this was an r squared, I could swap it out with x squared plus y squared. So I'm going to multiply both sides by r. And now I have got r squared equals 8r cosine theta. And that allows me to flop, or to substitute, sorry. So I've got an r squared is the same thing as x squared plus y squared, and I've got x is the same thing as r cosine theta. So this becomes x squared plus y squared equals 8x. And I want to go ahead and figure out what this is. So this is going to be a circle. I'm going to subtract 8x from both sides. And then I'm going to complete the square on x. So ignore everything else. How do I complete the square? Take half of what's fixing to be your middle term, so that's -4, and square it. So -4 squared is going to be positive 16. So I just created a 16 on both sides. I'm allowed to do that because I did it to both sides, so I maintain equality. And now when I factor just this part, I end up with x minus 4 squared plus y squared is 16. So this is the formula for a circle that instead of being centered at 0, 0, this is centered at 4, 0. So my center is at 4, 0, and my radius is 4. So you're going to find you're literally going to pick and choose graphs of a circle that has been shifted to the right 4 units. So let's try another one. I'm running out of paper, so we're just going to do it over here. So I've got r equals 2 sine theta. So r equals 2 sine theta. So notice again, if I had an r with multiplied to sine, then I could change that to a y. Well, and if I had an r squared here, I could swap it out with x squared plus y squared. So I'm going to multiply both sides by r. So I get 2r sine theta. And now I've got x squared plus y squared equals 2y. And then I'm going to subtract 2y from both sides. And I'm going to complete the square on y. So half of -2 is -1. Square it. So plus 1. So I'm going to add 1 to both sides. So I get x squared plus, factor this, y minus 1 squared equals 1. So now I've got the equation of a circle, but its center is now located at 0, positive 1. So it's shifted up 1 unit and its radius is 1. All right. So now we're going to identify and graph some equations. So the first thing that we're going to do, I'm actually going to just show you how to do one of them. because the rest of them you're literally just going to pick and choose. All right, so I've got r equals 8 minus 8 sine theta. So I want to look at my pretty pictures, and what I have is r equals, and I need my constant and my coefficient to match. So I've got 8 minus 8 sine theta. And what that's going to make is a cardioid. So when I'm looking at this, your option is going to be a cardioid that's symmetric to the polar axis, which is the positive x, a cardioid that's symmetric to the line theta equals pi over 2, which is the positive y-axis. And then look, I've got all of these options. So this one is kind of floating above, floating below, floating right, floating left. So, couple things. First of all, make sure you're in radians. Okay, so I'm going to hit mode. I'm going to make sure that I'm in radians, which I am. I'm then going to go down to this row, and I'm going to come over here, and I'm going to see polar equations. So I've got functions, I've got parametric, polar, and sequences. So in functions, we're in terms of x. So on your variable key, you got an x. In parametric, you're in terms of t for time usually. And so there's a t for time. In polar, you're using theta for your variable. And in sequences, you're using n for your variable. So this is your variable key. Whatever mode you're in, which we want, sorry, keep going. I want polar. Okay. And now whenever I press this key, it's going to start popping up thetas instead of x's. So when I hit y equals, oh my goodness, everything just turned into r equals. So when I graph this, I've got 8 minus 8 sine theta. So press your variable key, and there's your theta. Okay, and now if you look closely, you can figure out, because all of these are on the, I almost just dropped that. All of these are on the same scale. So negative 25, positive 25, negative 25, positive 25. And then you can kind of sort of count out from there how many circles there are. So I've got a 1, 2, 3, 4, 5, probably 5 or 6, whatever. So I'm going to change my window. And my theta, my x min, I'm going to change to a negative 25. My x max is going to be a positive 25. I don't care about my scale, and I can go from negative 25 to positive 25. And when I hit graph, look at that pretty picture. So I have a cardioid that is symmetric to the line pi over 2, because theta equals pi over 2, because I can fold it on what would have been the y-axis, okay? And then you know that it's going to be floating a little bit underneath. So that means that you can identify these. So I've got 6 plus 5 sine theta. Notice that your constant and your coefficient do not match. And your constant is larger. Okay? So my constant is larger, and they don't match. So I've got, what do I have? I just lost it. 6 plus 5 sine theta. So I have 6, which is larger than 5. 6 plus 5 sine theta. Okay? So graph that and just make sure that you change your window to correspond with what you need. Okay, so then you're going to graph a couple more. So you've got 2 cosine 2 theta, you've got 3 sine 5 theta. So you can graph all of these. And then this one, you've got an r squared, which you can enter an r squared. So luckily for you, you know at this point that cosine should affect horizontal movement, and sine should affect vertical movement. So you know that this is a lemniscate. Well, you're given one lemniscate to choose from, and it's horizontal. Okay. This one is going to actually be a spiral, and we're going to explore that one for just a second. So if I have r equals 2 theta, if I graph this, 2 raised to the theta, sorry. So r equals 2 raised to theta. Okay, r equals 2 raised to the theta. Well, if I graph that, okay, I get kind of a partial. I can get that it's a spiral, but it's kind of sort of weird looking. And so I know, because I've got a rose, and a lemniscate, I know it's going to be a spiral. But mine doesn't look like that. So first of all, I'm going to change my window. And I'm going to change my theta minimum to a negative 2 pi. Right now your theta starts at 0. Okay, well, I want it started at negative 2 pi just because I want to explore a little bit. And then we're going to go to a positive 2 pi, which is positive 6.28, blah, blah, blah. I don't care about my theta step. I'm going to zoom in on a little bit. So I'm going to go to a theta min. These are in terms of 4s and 5s. So I think I'm just going to go to negative 6 and positive 6. So negative 6, positive 6, negative 6, and positive 6. And when I do that, all of a sudden you'll notice that little bottom part right here was missing before. Remember that that's a negative angle. Okay, I would have had to swing down to get that. So I'm just going to come around and I notice that that's a spiral. So make sure you play with your window a little bit. So you've got some more that you can play with. And for the last two, what I want to do is look at how I can determine if where these two things intersect. Okay, so what I'm going to do first of all is the other ones are literally just identify the graph. Okay, on this one I've got two different equations. So I've got a 4 cosine theta. So there's my 4 cosine theta. And then I've got a 2 secant theta. So remember, I can do alpha y equals and hit enter, and that'll change it into a fraction for me. And I've got, instead of 2 secant, I've got 2 over cosine theta. Okay, my window, I am told to change my viewing window from negative 6 to 6 to negative 6 to 6, which I actually already did that a while ago. So when I graph these things, look at this pretty picture. I have a circle to the side, and then I've got a vertical line going vertically. Okay, so I know that I'm to the right of the line theta equals pi over 2, which is to the right of the y-axis. Okay, so I do know that this one's to the right, that one's to the right, but that's two circles. So this is my answer. Okay, look at it. I have, that is my answer, because that matches what I'm working with. So here's, that's making me dizzy. That's the pole, that's your polar axis, and then my circle and my vertical line are to the right of it. So how do I actually solve this thing? Because I want to know where these two things meet. So what I'm going to do is take my two equations and write them down. So I have r equals 4 cosine theta. And my other one, focus. Thank you. My other one is r equals 2 secant theta. Well, if r equals this and r equals that, I can set them equal to each other. So what I have is 4 cosine theta equals 2 secant theta. And I'm going to go ahead and rewrite 4 cosine theta equals 2 over cosine theta. And so I don't want my cosine on the bottom, so I'm going to multiply both sides by cosine. So it will reduce on the right, and on the left, I now have 4 cosine squared theta is 2. Divide both sides by 4. I got cosine squared theta is 1/2, because 2 over 4 reduces to 1/2. And then I'm going to take a square root of both sides. Okay, so cosine will equal plus or minus the square root of 1 over the square root of 2, which I'm then going to rationalize. So it's plus or minus 1 over root 2. So now it's plus or minus root 2 over 2. So there's 4 places where this is true in one lap of the unit circle. 4 places. That's going to be at pi over 4. That's going to be at 3 pi over 4. That's going to be at 5 pi over 4. And that's going to be at 7 pi over 4. So go back to your pretty picture. Okay, I am in quadrant 1, and I am in quadrant 4. So the 2 places that this is going to work is going to be at pi over 4 and at 7 pi over 4. Okay, now when I do that, I need to figure out because I need polar coordinates. So I just found 2 thetas. So I still need to find the radius from there. So I've got the one for pi over 4, and I've got the one for 7 pi over 4. Well, now I need to know what the radius is. So I'm going to take pi over 4 and put it into either equation. I prefer this one. Okay, so my radius will equal 4 times the cosine of pi over 4, which is going to be 4 times root 2 over 2, which is going to reduce to 2 root 2. Okay, so here my radius is 2 root 2. Well, now I need to do it for 7 pi over 4. Okay, so 4 times the cosine of 7 pi over 4 gives you the same cosine. Okay, because you're in quadrant 4, so your x's are positive in quadrant 4, so it reduces to a radius of 2 root 2. Okay, so you may now do the rest of these, and that's it. So make sure that you are paying attention to your restrictions for your windows on your calculator so that you can see the shape the best that you can, and I will see you for the next section.